So let's take a look at an example here. We have the graph of this function, f of x equals 2x squared plus 5x minus 3 over x squared minus 9. You might remember functions like this from pre-calc last year. So these rational functions, a lot of times they'll have these graphical features. So like there's a hole at -3, and it tells me here that this y value is 7 over 6. So I know that this point right here is -3, 7 over 6. So we'll keep that in mind. I also notice there's a horizontal asymptote here at y equals 2 and a vertical asymptote at x equals 3. And so what we're going to do now is connect the ideas of pre-calculus to how we actually write those out in calculus. So as x approaches -infinity, the graph of f of x approaches blank. And so let's think about what that means. So as x approaches -infinity, that really means my left end behavior. And so I'm looking at the left piece of the graph as it approaches -infinity. So the x value is approaching -infinity. The y value seems to be approaching 2. So the way I say that in calculus is limit as x approaches -infinity of f of x is equal to 2. For the right side, as x approaches positive infinity, that's my right end behavior. The graph of f of x approaches blank, so I'm going to take the right piece, try to follow that and see where it's going, and it also seems to be approaching that horizontal asymptote of 2. Now notice here on my infinity and -infinity, I didn't put any direction symbols after, so there's not a plus or a minus, because if I'm going to infinity, I can only come from the left. If I'm going to -infinity, I can only come from the right. So we just don't actually worry about it. Let's take a look at -3 now. So as x approaches -3 from the left, the graph of f of x approaches blank. And so I'm looking at -3. So -3, that x value is right here. And I don't actually care that this is an open circle. What I'm looking at is what's happening around -3. So from the left, if I follow that graph, trying to see what y value that approaches. And it approaches the y value of that hole. I can see it's getting closer and closer to the y value of that hole. I know that this is 7 over 6 because that was given to me in the problem. Otherwise, if I were just looking at this graph, I might estimate it as about 1, but they tell me it's 7 over 6. So limit as x approaches -3 from the left of f of x equals 7 over 6. As x approaches -3 from the right, I see that going the same way. It also approaches 7 over 6. So limit as x approaches -3 from the right of f of x equals 7 over 6. So again, be careful with that notation there. The negative and the positive after the -3 denote the direction, not a positive or negative value. All right, as x approaches 3 from the left, what is the graph of f of x doing? So if I look at my graph at 3, I notice that I have this vertical asymptote. And so from the left, I'm going to go to the piece from the left and move closer and closer to 3. So notice I'm from the left. I actually move right, but it's from the left. If I follow that graph, get closer and closer to 3, I can see that my graph is going down towards -infinity. So the limit as x approaches 3 from the left of f of x equals -infinity. As x approaches 3 from the right, I can see that that right piece of the graph, as I get closer and closer to the asymptote, is moving up towards positive infinity. So my limit as x approaches 3 from the right of f of x equals positive infinity. All right, so let's actually talk about when a limit exists. And so this is the limit existence theorem. I'm going to write down the really complex theorem first. A lot of times you'll see these theorems that have complex formulas, and then we just kind of have to translate them into better English. So limit as x approaches c of f of x, this is the general limit, exists if and only if the limit as x approaches c from the left of f of x is equal to the limit as x approaches c from the right of f of x is equal to L, where L is a real number. So there's two important things there. First of all, your left and your rights match up. Your left and your right limits match up. And then also the L is a real number. So what that means is when we have infinite limits, our limit doesn't actually exist. And so we could be specific and say the limit approaches infinity, or we could just say the limit doesn't exist. If it asks for just a left or a right limit, we do want to say infinity or negative infinity when we can. Okay, so let's take a look at some examples. In number 1, it first asks us for the limit as x approaches 1 from the left. And so again, I'm going to focus in on where x is 1. Not actually what the function value is. I'm looking where is the graph approaching as x approaches 1 from the left. So I'm going to go on this left piece and approach 1. And that y value is approaching 1. For B, it's looking for x approaching 1 from the right, so I'm going to go on the right piece and move it towards x equals 1. That y value is approaching 2. Since the left and the right values aren't the same, so A and B are not the same, then I would say the limit as x approaches 1 does not exist. F of 1, though, is just the actual value if there's a filled-in point, which there is in this case. That is 2. That f value doesn't have anything to do with those limits, okay? So that could exist, it could be undefined. That doesn't affect limits. Limits are what is going on around that x value, not at the x value. Let's try another one. All right, so number 2, limit as x approaches 1 from the left. So here's 1. I'm looking at the left piece and moving towards x equals 1. So this piece of the graph here, that y value is approaching negative 1. If I look as x approaches 1 from the right, that graph is approaching positive 1. Since those don't match up, once again, my limit does not exist. And f of 1, some other value, it's 0. All right, example 3. The limit as x approaches 1 of f of x from the left. So here's 1, I'm going to go from the left. That is approaching positive 1. As x approaches 1 from the right, also positive 1. Since those two match up, so they're approaching the same y value, I can say that the limit as x approaches 1 is 1. F of 1, though, is undefined. I see that open circle there, so I say undefined. You can also just write UND if you want. So please notice here that when we talk about limits, we say that they don't exist. If we're talking about function values, we say they're undefined. Number 4, limit as x approaches 0 from the left. So here's 0 from the left, that's approaching 1. From the right, also approaching 1. And so then the limit as x approaches 0 of f of x is 1. And then f of 0, I just look at the graph value. There's no hole or anything there, so I know it is just 1. So in this case, all of them are the same. And that's something called continuous, which we will talk about in the future. All right, we've got a few more examples left. Number 5, limit as x approaches 2 from the left. So here's 2. I see that asymptote from the left going down to negative infinity. From the right, up to positive infinity. So that limit does not exist. F of 2, I have a vertical asymptote here. There's no other point. That's undefined. Example 6, x approaches negative 2 from the left. So at negative 2, I see this asymptote from the left. I am approaching negative infinity. From the right, also approaching negative infinity. So since those are approaching the same direction, I could say the limit is negative infinity, but also general limits, if they are infinite, technically do not exist. So I could give either of those answers for C. However, for A and B, I want to give the specific direction since I can there. In this case, even though I have a vertical asymptote, this function has been defined at -2 as 0. And I can tell because I see that point right there. So watch out for those. Okay, now for this last example, we have a graph with a bunch of different points that we'll be checking out. So the limit as x approaches -3 from the left. So -3, I see this asymptote. From the left, I'm going to be approaching positive infinity. For B, limit as x approaches -5. Notice there's no direction there, so I'm going to come from the left and the right. So here at -5, I notice there's this point here, but then I'm up here is the rest of the graph. So for limits, I care about the graph and not like that single point. So from the left and the right at -5, I'm approaching the same y value, and that is 4. Limit as x approaches -1. Again, without the direction means from the left and the right. At -1, I can see the graph is approaching -1. Limit as x approaches -3. So that's from the left and the right. Those are not going in the same direction, and they're both infinite. So I will say this limit does not exist. For E, limit as x approaches 2 from the left. 2 from the left is approaching 1. 2 from the right, I'm up on this other piece. That is approaching 6. So the limit as x approaches 2 does not exist, since the limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right of f of x. The limit as x approaches -infinity, so that's my left-hand behavior. I can see that's approaching a y value of 2. I have that horizontal asymptote. And on the right side, my limit is going up towards positive infinity. So I could say is infinity, or I could also say does not exist, since the limit is infinite.